Let's talk about observability in this lecture. Observability means in our microservices world, we have multiple microservices, right? So what is happening inside those microservices? How to know? So the topic that discusses about the internal state of each of the microservices is observability. Assume there are three microservices, A, B, C. They are deployed in a Kubernetes cluster. Assume this each one is one node. So what's happening? What is the state of this microservices? What's internally happening? How to find it out? We can find it out by finding the external output. Say it provides some log file. The state of this one can be found out from the external output. By doing understanding this external output, we will do an infer to find the internal state of the system. So basically we measure something on the external of the values. Based on that we infer what's happening inside the internal state of it. So this is what is observability. So why do we need that? We need that because we want to know how our microservices are doing. We need to know what is the throughput of each of the microservices, how many success failure requests are it's addressing, like how many requests it is successful, how many requests it is failing to respond, and what is its utilization of CPU and memory, like how much memory it is using. And we also need to know network related issues and any business related metrics, like if I want this microservice should respond within some milliseconds, is it actually meeting that requirement or not? So in order to understand all this, how microservices are performing in an environment, we need to focus on observability, and observability can be achieved by seeing the state, external state. We try to infer what's happening in the internal state. And there are three ways. So we can say logging, like we see log files of each of the microservices and understand whether it is working or not. We also see some metrics like how fast it is responding, and we will also do a tracing. Tracing means if a request is sent from A microservices to B and sent to C, then we can also trace like how fast it is and how it is happening, whether it is responding or not. Let's get into some details of each of them. So logging is about recording the events. So an event is a request came to a microservices. It has processed the request. It has sent a response back, right? So these are different events, and it can be related to metadata. Like what we can log is the log file can consist of what happened, what is the output, like in the process, what is the result that has come. Then metadata, like when the request has reached the microservices, what is the status of the microservice, who has initiated that. So a lot of information, the metadata information, and also the business logic related information, or the whatever output we want to give in the log, we can record. So logging gives this information, right? Then we have metrics. Metrics is the derived information from measured data. So say for example, we measure how many transactions are happening per second. So it gives one measure, right? So number of transactions per unit time, like 1 minute. So if I can say 1,000 transactions per minute, and then if I work on the algorithm, maybe I can make 5,000 transactions per minute, right? So finding the metrics from the data gives us a measure on how the application is performing, how the microservice is performing. It can be something like number of successful or failure uh, responses in a given time, like out of 100 requests, how many are successful. We can also measure latency, like how much time it is taking to respond back. So these are all metrics which we can analyze them to understand the trends, and then we can also set some alerts, like if the response is not coming within say 2 milliseconds, maybe we should reinitiate the call, maybe we should terminate that. So we can also set some alerts and then analyze the trends. So metrics is very useful to check how our application is performing against the targets that we have built it for. Then tracing talks about considering the order of such events, like A microservices is calling B, maybe A is calling C, and C is calling D. So we can find out how the trace of a request is going from one service to another service, so that we can debug any scenario, right? Suppose A didn't get the expected response, so we need to know whether it failed at C or it failed at D. Since these are all individual microservices, uh, each one log will not show. It will not show whether it failed or success. It will not show whether it failed or success. Overall, it may throw some errors, but overall, A need to identify what happened to this request that went across these multiple microservices and finally got the response, right? So we need to trace them, what happened inside each of the microservices. So let's see little more detail. Log, right? So how do we do these logs? Now you know that there will be hundreds of microservices, right, in one environment. So suppose this is one microservice and this is another microservice. Now what happens is, if these are deployed in Kubernetes cluster, assume there will be a need for this microservices to push the log or to publish the log to some central server. Assume there is another microservice, this also does something like push the log files. So we need one central place where we need to collect the logs, right? So we collect the logs and then we need to process the log. Let's see what happens. So log aggregation talks about this collection of the logs and processing of the logs. So how it does is, microservices publishes log files and we will need to collect these logs, store them. We also need to read and parse the content, and sometimes it comes in different formats, like this service can give a different format, this can give a different format, right? We also need to reformat once we have the data, and then we need to aggregate. Sometimes we have to aggregate the same say there is a request coming from A, the same request need to be seen for C, so we need to aggregate the log of A for that request and the log of B for that request. So we aggregated the request level. And also we may have to publish this data to some other system like S3 or Kafka, or some other system which need to further process the data, right? So log aggregation talks about these concepts, like publishing the logs, collecting the logs, storing all this data, right? Now this can be achieved having an agent in each Kubernetes node. Say for example, we will have an agent which will push the logs, and then these logs are published to the central server. Now there are tools like Fluented, Logstash. These are all different tools for doing this log aggregation. Okay, so basically what we are saying is, in a microservices world there are multiple microservices. Each of them have log files. We need to collect all of them to central server and analyze them. So we have tools for that. Now for metrics, let's see how we can do. For example, we use a tool called Prometheus. This is what I want to discuss, what features it will provide. There are many tools and most of them provide a similar kind of features. But let's understand one, what it does. As we said, metrics are derived from measure data. If you are measuring the performance of a microservices, you will measure number of responses it has responded, or number of successful messages that it has given in a given unit time. So like this, we need to find out some metrics, and manually collecting the metrics is not the easy way, right? So there will be some tools which are available for us to do it. So let's see. Prometheus is an open source system for monitoring, alerting. So these two are important for monitoring and alerting. Prometheus is a very good tool. So all our microservices will expose their own endpoints to expose their metrics outside the microservices, and Prometheus will periodically poll those endpoints. That means, so a Prometheus server, whatever microservices registered with it, it will poll and then gets the logs. Okay, like log aggregation. And once it has the logs here, it provides some tools for us to analyze this. How do we read these log files? So the first thing is a PromQL. Similar to an SQL, where if we have a relational database and then we have multiple tables, we write an SQL query to fetch the data what we need, right, from one table with some conditions, where clauses and all. Similarly, Prometheus provides a PromQL. It offers a flexible query language that supports complex queries on time series data. You can aggregate, filter, and transform metrics data to create custom visualizations and alerts. So it's a very powerful language which works on top of the logs that it has collected. Okay. Now it also provides time series analysis. We need to know time series analysis because how our microservices is responding for a, say for example it started every 1 hour, how it is responding. Maybe say for example you take CPU utilization, is it going high or is it going less, or we'll be able to see the trend. So we need to see the time series analysis, and the query language allows us to apply functions like rate, average, and sum over some time windows. There's a lot of features available, but these are automated. I mean, these are easy to use so that we don't have to build them again. So like trend analysis, anomaly detection, and all these microservices can be done in Prometheus. There is also another one called rule-based alerting. Alert, right? So why we need microservices? Because we want to provide a zero downtime. We want to provide a high availability. We want to provide fast responses, right? So in such a case, if something goes wrong, we need an alerting mechanism. We can't be always reading logs, right? So this tool will read the logs, and we can configure an alert based on a metric. So we can define an alert based on a metric. Like if CPU utilization is more than 90%, say if CPU utilization is more than 90%, send me an alert, right? So you can trigger alerts with specific thresholds are crossed, like latency, for example, or memory usage increases. So this is a very good feature where you can set a rule, and based on the rule, Prometheus will send an alert. Okay. Now, apart from that, yeah, how it does is it has a alert manager. So integration with alert manager, which can route alert to different destinations, like it can send an email, it can send a Slack message, it can send a message to PagerDuty. So manage all these things, like handle deduplication and grouping of alerts. So alert manager, which is the feature provided in Prometheus, provides all these features. So it should not send a duplicate alert. It should send it again if it is required. It can do a grouping of the alerts. It can send an email like that, right? And Kubernetes native. That means Prometheus is works seamlessly with Kubernetes environment. We know that Kubernetes is the world ruler in providing the orchestration of the microservices, and Prometheus works seamlessly with it. That means all the Kubernetes environments can use Prometheus, easily configure, and then can take advantage of the features provided here. It provides a native support for Kubernetes services, service discovery, and monitoring of pods, nodes, and other Kubernetes resources. So it is very much easy to use with Kubernetes and works seamlessly. Now, there are another a couple of things we will see, which is service mesh integration. So as we discussed, service mesh is a infrastructure level layer which provides a lot of non-functional requirements to the infrastructure layer so that the developer can focus on the business requirements. Now, the service mesh integration can be done with Prometheus. Prometheus can monitor service mesh deployments like Istio. Istio is a service mesh provider to gather metrics and inter-service communication, request latency, and error rate. So, like this, at the service mesh layer also, Prometheus can capture the details. It is integratable with Grafana. Grafana is a UI that does the visualizations, like instead of just the tables and data, it can show some charts, which provides a robust dashboarding solution for creating custom views and microservices metrics. So Grafana is a UI, graphical UI that provides like charts, dashboards, dashboarding feature on the data that we collect from Prometheus. So it is easy to integrate with Grafana. And federation is an important feature where federation talks about Prometheus support, which enables you to aggregate data across multiple Prometheus servers. So I have one set of microservices which is run by one Prometheus server, and then different microservices and another Prometheus server. I can aggregate these two. So this way, multiple Prometheus servers I can aggregate. Is very useful for large scale environments with multiple regions or clusters, where you need a global view of the metrics while maintaining local observability. So imagine from each microservices to each cluster to a multiple cluster level details and graphing and analysis can be done by the federation capability provided in Prometheus. So Prometheus provides a lot of features which are very much required for maintaining how the microservices are running, their internal state, and then observing their metrics. Now let's look at distributed tracing. So as we said that each microservices has its own log. Say if microservices A and B and C, there are three microservices where a request comes from A to B and B to C. Now we want to trace the request. Trace means it started here, it went to here, step 1, then step 2 is it came here, and step 3 is it came back to B with a response, and B sent a response back to A. So multiple steps are there. So we need to trace each of the requirement. So tracking a given request which spans across multiple microservices. This is called distributed tracing. Due to the nature of microservices, in most cases, to cater a single request from a client, more than one microservices are consumed. As we know, like, so for one request, there will be multiple microservices serving that request. Now we need to understand two words, span and trace. So span is a work in an individual microservice. So what's happening inside the microservice is called span. Span have a parent-child relationship. So for example, microservices B span is a child of the span of A. Okay, let's assume A is an order service, B is an inventory service. Now C is a payment service. Okay. Now span D for logistic service. So we have one more service, logistic service. Assume order service invokes inventory service, which invokes both payment service and logistic service. So it invokes both these two services. So how do we trace whether these are successful or not? So if each one has their own span, we'll say span of the request in each of the microservices, and a trace is a tree-like structure for multiple spans in a microservice architecture. So what the tree looks like? So this is a tree like A, B, and has two C. So the parent of C and D is B, the parent of B is A. So it's like a T structure. Now how it works out is that there is a trace ID. So trace ID helps to correlate messages between microservices. What we mean by that is it starts with 2 points. One is span, okay, suppose it's A, and then trace, say 1. Now when it comes to B, span B, but trace is 1. Now it comes to span is C and trace is 1. So here also span is D and trace is 1. So here trace is same, right? Now by aggregating all the traces across this one, we will come to know what happened in A, what happened in B, what happened in C, what happened in D. Okay, so trace helps to correlate messages between microservices. Once all the logs from different microservices are published into a centralized tracing system, given the trace ID, we can trace the message across different systems as we explained. Now let's see some format. Right? We know log format, how to format a log for any, say, Spring Boot application. Using trace and span, it looks like this. There is a timestamp, there is a log level like error or debug or what we want to say. Then there is a service identifier like service A, it's a payment service or it's a logistic service. Then trace ID, which is an auto-generated ID. Then span ID, which is specific to that microservice, and then the data that it want to log, maybe an exception or maybe some data that it want to output into the log. So this is one example of a log format. So here if you observe, we have trace ID, span ID. These two are important things. Based on this, we will be able to figure out what happened across multiple microservices. So this concept is called distributed tracing. Okay. Now there is another concept I want to talk about. What if the format of this trace is different from this trace and this trace? So it may be difficult to analyze the data. It may be difficult to find out how the trace is happening. So there is a need for all these microservices to adhere to some standard of logging, right? So there must be some standard of logging so that it is easy to analyze across different microservices. So there is a concept that came up, is called open tracing. Now, when different microservices in the same microservices deployment are used for different tracing modules, which has different definition of spans and trace IDs, then we can correlate the logs. So there must be some defined open standard which all the tracing modules adhere for a given architecture. So we need to define what will be the standard of logging, which is to be followed by all the microservices in the given application. So open tracing has work across multiple programming languages, right? So what happened is there are some standards that are developed and there are some applications that are built around it. There are several implementations of these APIs. For example, Agar is an open source distributed tracing system like we see in Prometheus. Agar is an open source distributed tracing system developed by Uber, and has supported for open tracing and includes open tracing client libraries for several programming languages. So if the microservices is developed in Java, Go, Python, Node.js, C++, or C hash, these different applications in different languages can follow the distributed tracing system like open tracing standards, so that it is easy for the tracing applications like Agar to understand and analyze the logs, right? So what we have to understand is that observability needs three things. One is logging. All things happen in the logs. We need a different way of logging. We need to log the trace ID. We need to log the request ID. We need to log the system. We need to log the span. So timestamp like that. Then we need a systems to pull all the logs into a system, into a central system, and then analyze them, and then arrive at some metrics. So there is the tools like Prometheus which does this. And then when we have to deal with the multiple different programming languages and different type of tracing, we need to adhere to standards like open tracing standards, so that it is easier for us to observe how the microservice is behaving, right? So open tracing is an important guideline we need to follow to make observability easier in the environment.